Driving at night increases risk of impaired visibility and poor lighting conditions due to situations such as blinding high beams and external light outages. We propose Project Brightlight as a precautionary measurement to combat these issues. This system directly addresses these issues through the use of sensors and the ATmega microcontroller. The circuit senses the oncoming headlights and switches its high beam to low beam to avoid blinding the other driver. The system senses whether or not an exterior light is out and notifies the driver of its location. We set certain requirements and ran a few tests to see if the conditions were met. We tested the effective range and sensitivity of our circuit to determine if the light is accurately being detected. The outcome of the light detection determines if the light switches from high to low. We simulated a situation where an exterior light went out. This would show if the system detected and notified the driver that the bulb is blown.
Our sensing system responds to the headlights of an oncoming car and switches from high to low beam. After the light presence is gone, the system would automatically revert to high beam. For our light sensor, we chose a PS5022 phototransistor that is 1.7 millimeters in diameter with a collector current of 20 milliamps. The sensitivity of the sensor is inversely proportional to the current flowing through the phototransistor. We chose a current limiting resistance of 51 kiloohms, which set the effective sensing distance to 2.5 feet. The light switching aspect of the project was implemented using the ATmega 322P microcontroller to monitor the output of the phototransistor. The output voltage dropped with respect to the distance of the light source. We programmed the threshold of 2 volts as a trigger to the microcontroller to switch between high and low beam. Before the switch, there is a 3-second delay to prevent the system from creating a strobe-like effect. The system responds to the light source once the distance is less than or equal to 2.5 feet.
More often than not, a blown external light goes unnoticed, which can lead to unnecessary consequences. Another feature of Project Brightlight is our light-out detection system. In series with the LED representing a headlight bulb and a 160 ohm resistor, we have implemented a UA741 op-amp to monitor the voltage. While the light is on, a voltage of 2.1 is monitored by the op-amp, indicating it is still on. Once the light is blown, the voltage increases to 2.7 volts, surpassing the 2.5 reference voltage and indicating the light is out. To represent a blown bulb, we have implemented a switch to cut off the LED. Once the switch is flipped, the ATmega chip receives a low output and a signal is sent to the LCD to blink left beam out. In order to eliminate some of the wiring within the external lighting system of a vehicle, we are using wireless communication. Coupled with our light-out detection feature, our project uses wireless communication to indicate when any external light is out. This was achieved with the use of an RF link transmitter and a receiver module. An ATmega chip was programmed to monitor the light-out detection portion of our circuit. When the transmitter receives a high input, this is relayed to the receiver to output left beam out. Our light switching sensor consists of a phototransistor connected to a microcontroller, constantly monitoring the output voltage. When light is detected, the output drops below the 2-volt threshold. This indicates the microcontroller to switch from high to low beam until the oncoming light source is no longer present.